What is up, guys? Welcome back to another GeekaWhat video. In this one, I'm going to be walking you through the best $1,000 gaming PC that I believe you can assemble right now. Part prices for certain components are the lowest they've been in ages, allowing us to build a really capable 1080p and 1440p system for under that $1,000 budget. Let's do this. The Cooler Master Tempest GP27U gaming monitor is a stunning quantum dot mini LED monitor that boasts a huge 576 local dimming zones. The crisp, high-resolution 4K panel provides stacks of detail and is backed up by a competitive 160Hz refresh rate. With a 1 millisecond response time, 27-inch form factor, and HDMI 2.1 support to run the latest consoles at up to 4K 120Hz, it really does tick a lot of boxes. You can learn more about the GP27U at the first link in the description below. This video is going to be split into 3 core sections. First, I'll be running you guys through the parts I chose and how I picked all of these components before showing you how to assemble the system, and rounding things off with the most important bit, the performance benchmarks later on. And we're testing a lot of games on this build to make sure it stacks up. Now, at the heart of any good gaming PC is of course the GPU, but also the CPU. These are the 2 bits that are going to define just how strong or not so strong your PC build will actually be. Let's look at the CPU to begin with, shall we? This is the AMD Ryzen 5 7600, a chip that I wouldn't have necessarily recommended 6 months ago. Not only has it come down significantly in price, but cheaper A620 motherboards like this one, which we'll come on to later, are now available, making an AMD Ryzen 7000 ecosystem cheaper than ever. With 6 cores, 12 threads, and a boost clock speed of up to 5.1 GHz, this thing is a monster for single-threaded performance, and it's going to tick loads of boxes for the system today. The GPU choice is another strong area too, with AMD's RX 6700 XT coming in strong. Now, GPU selection at the moment is kind of tricky. Both AMD and Nvidia's new cards at this price point have kind of flopped. And there's one main reason for this, and that is this number, the video memory. The 4060 and 4060 Ti, for example, only come in with 8 gigs of VRAM, and that's fine for gaming at 1080p now, but to game later at higher resolutions, it won't be enough. That makes cards like the last-gen 6700 XT a great shout. AMD, by the way, are killing it on price to performance. The only other card I'd recommend you pick up instead of this is the 6750 XT, which is going to give you 5, maybe 10% if you're lucky more performance, but there really isn't that much in it. And this is going to cost you less money. Motherboard I talked about earlier, A620 ASROCK board. Let me just show you what particularly I like about this motherboard, because there's a lot that I like about this motherboard. I think I paid like £120, about $120 for this board when I bought it. And you can see it looks a little bit more on the basic side. Not only do you get 4 RAM DIMMs, something often not afforded on cheaper boards, giving us dual channel memory support. We've got room for PCI Gen 4 NVMe drives, our PCI Gen 4 slot for graphics cards, and on the rear, a pretty solid I/O with Wi-Fi 6E and our USB-C, so 10 gigabit on both Type A and Type C connections. But it gets even better than that, as we also have Type C on the front panel, plenty of fan headers, couple of USB. It just has everything that we need. And of course, that AM5 socket, one of the most upgradable CPU sockets we've seen in recent years. Future Ryzen chips, for context, will support this AM5 socket for generations to come, meaning a simple BIOS update means you can upgrade your CPU without changing the board. Massive win. Now, I think it's probably a good time to actually start building this system up onto the motherboard, and the first part I'll be adding in, other than the CPU, is this, the memory. I've picked up a 32GB kit of Corsair's Vengeance RGB DDR5. DDR5 memory is another reason I wouldn't necessarily have recommended a Ryzen build previously. It was so expensive, but the price of this has now come down, so it's easily able to slide in, clicks into place without too much hassle, and isn't going to cost us a fortune. CPU is next up. I'm going to line up the triangle on the Ryzen processor with the triangle on the socket cover, lift up the socket and drop, not quite like that, gently drop the processor into place. Return the arm. Whoa, we need an action replay of that. The black plastic will pop off. Normally not quite with so much aggression, but it's off, and I suppose that's all that matters. Storage is the other part that I'm going to pop into the build now, and that's where our SSD choice comes in. The WD Black SN850. I don't want to harp on too much about how cheap PC hardware is, but Gen 4 NVMe drives have come down so much in price. This one, for example, on Newegg is $89 for a terabyte, but if you spend another $15, you can get a 2 terabyte Samsung 980 Pro for $100, $120. I mean, it's insane. This is a really fast Gen 4 drive with speeds that exceed 5, 6, even 7 gigabytes per second. It means for a more budget-friendly build like this one, you don't have to, and frankly shouldn't, scrimp out on storage. So this is going to work amazingly well, and pops under the M.2 Armor heat shield on the motherboard. Top tip, don't pick up an SSD with a heatsink on, as your motherboard will have one anyway, and that will look a lot cleaner than the SSD's inbuilt solution. The heatsink drives are more for like the Xbox and PS5, where cooling isn't quite so well catered for. But we're on a PC, so we don't care about that. We just care about our SSD motherboard cooling. The only thing then really left to add into the motherboard is the CPU cooler. Now, this is a bit of a diamond in the rough. Typically, when people look at buying a budget air cooler, they'll buy a Cooler Master Hyper 212 RGB or the Evo or whatever. Don't do that. Buy this instead. This is the Deepcool AK420, and it's better in basically every single way, while also costing less money. So you've got the 120mm fan that's mounted on the front, fairly standard. You can buy it with a second fan or even a second heatsink if you need. Not that that'll be relevant for this build, as overclocking isn't a factor. Available in white or black, the white finish is absolutely immaculate, and you can see we've got our 4 heat pipes that go all the way through the heatsink, down past the copper contact block for the cooler, and back up. This is going to be a lot quieter than the included stock cooler, keeping thermals lower and making your build, it's a quality of life upgrade, basically. If you can afford a good cooler, you might as well get one. I am going to install it now. I will take the fan off though, as that's just going to get in the way and can be easily added back on later. And doing this stage of the build early, before getting the motherboard into the case, makes the cooler installation a lot less stressful. The only problem is, there's lots of mounting hardware. Coolers is the area where you do want to refer to the manual, so let's have a look. AMD AM4, AM5 socket. How do we do it? It actually looks surprisingly simple. First things first, I need to add on these orange, sort of like, don't know what to call them really. Then the metal plate goes on with the screw posts on the left and the right hand side, so not top and bottom. And then that just screws into place. A little drop of thermal paste onto the CPU, about that much is good. And then the cooler just sits very nicely on top. A couple of screws. You can start these off by hand, but finish them with your screwdriver. And as I said earlier, we'll be saving the fan for a little bit later, as it's far easier to put on afterwards than it is to put on now. And a good test of whether the cooler is sufficiently installed or not is when you've actually finished tightening the screws, you should be able to lift the whole thing by the cooler, and it all feels very solid.
3 days later.
I can do it with a tennis racket really well, but that was a bit painful. The now completed motherboard assembly also gives a little bit of a hint to the overall colour scheme and design for this build, if the white power supply didn't already give it away. And that is where this comes into play. Now, this right here is the Montech AIR 903 Max. Now, in a recent trip over to Computex, I saw this case on display and really liked the look of it. At $79, it's got 4 included fans and like a really cool detachable design. Let me just open it and show you what I mean. One of the things that I really like, for example, is that the front mesh panel is actually detachable without requiring to take off the entire frame for the front of the case. Now that means you can go in and change your fans, get your radiator installed without needing to pull off this thing. Now, it still very easily clips off, but it's just a nice quality of life feature. Not only that, but the 3 included 140mm fans at the front of this chassis, which are a little bit overkill, admittedly, for the build today, mean that we aren't exactly going to have any problems in the airflow department. Tempered glass, triple RGB fans up front, and it even supports large motherboards if you want to spend a bit more money and go a bit more ham on the feature set. Oh, and I forgot to mention the fact it's got a fan hub with room for up to 6 fans, and it even wires up the included ones so you know which are the front and which are the back. 3 RGB ARGB headers with 3 more spare. It's really well done. And I've got to say, I'm really impressed. A quick cursory glance, and I think a couple of the standoffs are in the wrong place. So I'm going to move any of the standoffs that are not in the right holes and move them so that our micro ATX motherboard is better supported. If you've got an ATX board, they'll all be already in the right locations. All I then need to do is slide the motherboard into place, screw it down screw by screw, and of course, don't forget to install the fan onto the CPU cooler as well. At this stage of proceedings, this is going to be wired up to just the CPU fan header at the top of the motherboard. The GPU is then the next part on the the list. Now, I don't think I've actually opened this card before, so let's pop open our Sapphire Pulse 6700 XT. I'd kind of hoped from the box this might be a bit more white, but unfortunately, finding white GPUs is very tricky. Almost more tricky than it should be. It is, however, a very, very good looking GPU. Let's take the plastic wrap off. We've got two fairly large fans actually, quite a nice modest heatsink design, accents of red with a metal backplate. In terms of power connectors, an 8-pin and a 6-pin. So fairly power hungry, but not ridiculous. Don't need 1,000 watts or anything stupid. The main kicker with this card is the performance and the price. You can find this thing for a shave over $300. Various different coolers available at that price point too. 12 gigs of VRAM makes it ultra future-proof for 1080 and 1440p gaming. And as you'll see in the benchmarks in a couple of minutes time, it is amazing. It is so, so good. Better than a 4060, better than a 4060 Ti, better than a 7600. It just wipes the floor with everything, and AMD should be commended for the amazing price to performance on this card, unlike some of Nvidia's offerings, which are ludicrously expensive at the moment for no good reason. Anyway, we're not being negative in this video. We're gonna give it the positive vibes and go ahead and actually screw the GPU in. So a quick glance at the motherboard. Yep, it's the top two slots, so this slot here and the one just below. He says while unscrewing the wrong slot. No, oh, disaster. No, stop moving. Oh, no. Heavens above. And then the card just slots into place. Nice and simple. Yeah, hey, there we go. Lovely stuff. Card's in, couple of screws, and the power cables to go in next. In terms of where the power will be coming from, I've picked up this, the Corsair CX750F. With 750 watts of 80 plus bronze efficient power and a fully modular interface, you can't really ask for much more, and I'll be plugging the matching white cables up into the build. Power supply screws into the bottom, with the fan pulling air from underneath the case, while our power cables run to the CPU in the top left corner of the motherboard on the right hand side, and GPU, of course, on the graphics card to give the whole system the juice it needs to get going. And then the build is ready, and in theory should turn on A-OK. There's a little bit of RGB in the top corner of the motherboard just here, but will the rest of the system boot? Let me jump round, use a screwdriver to jump the pins. Oh, hello, we've got fans and RGB. Look at that. The RAM's lit up. A bit of cable management to do. I don't really like how the GPU connector is sitting right now. And I think if we jump through the LED button, yes, loads of different effects. RGB, you can see if I take that off. Fans are indeed spinning, and we're ready to actually try some games on this system. So I'll rejoin you in a moment for some detailed gaming benchmarks. But first, let's see how good this looks in the only way we know how. It's time for a GeekaWhat montage. When it comes to performance, it really is amazing how much you can get for a $1,000 budget. Let me show you just what the 6700 XT is capable with its awesome straight rasterization performance and plentiful amount of VRAM. In Hogwarts Legacy at 1440p high settings, one of the latest AAA titles, max right out, the build pulls in an impressive 68 FPS. That's just shy of 70 frames per second at 1440p. Games like Warzone 2 also stack up well. At 1080p high settings, for example, the build pulls in just shy of 100 frames per second, with 96 FPS on average. 90 and 99th percentile results were good too, with the lowest figure at 82 FPS. At 1440p, frame rates stay solid. 86 becomes our average, with 82 and 74 for the 90th and 99th percentile results, showing this is not a build to be messed with. Move through into Fortnite at 1080p competitive settings, and it once again stacks up well. 195 FPS WoW to be precise, giving us that competitive esports experience. Apex Legends also delivers strong frame rates too, 1440p high, and the build clocks in at 180 frames a second on average, with 90 and 99 percentile results in the region of where you'd hope for a build of this caliber. Overwatch 2 was also impressive, 1440p Ultra here, delivered 178 FPS on average. All the frame rate data was gathered using both MSI Afterburner's Riva Tuner and Nvidia FrameView. Finally, to wrap things up, we also threw a little bit of GTA 5 in for good measure, 1440p high, the build well excelled 150 FPS, showing that this system isn't just a one-trick pony, whether it's the latest AAA titles, esports games, or older games like GTA 5, this PC has you covered. AMD are killing it at the moment with great value GPUs, and the 6700 XT in this build is no exception. If you enjoyed this one, make sure to give it a like rating, get subscribed. Thanks for watching, and as always, we'll see you in the next one.